All right, in this segment on dimensional analysis, we cover the main type of math that's used in chemistry. We'll use this quite a bit throughout the year in other topics too, but for now, we're applying this to two things that are familiar. One, some basic English system conversions, and also some conversions in the SI system. Dimensional analysis is based on two of the most simple rules in math. The first rule is anything divided by itself is equal to 1. So 8 divided by 8 is 1, 16 divided by 16 is 1, 865 million divided by 865 million is 1. Of course, x divided by x is also 1, and apple divided by apple would be 1. In addition to that, we have a second rule that says if you multiply something by the number 1, it does not change. It stays the same. So 8 times 1 is still 8, 12 times 1 is still 12, and apple times 1 is still apple. In dimensional analysis, we use something that's called a conversion factor. Now, on the previous slide, it said a conversion factor is a ratio equal to 1 that shows how two measurements are related. Ratios can just be written as a fraction. This is the relationship between feet and inches. 1 foot is equal to 12 inches. Written as a ratio or as a fraction, we end up with 1 foot over 12 inches. Since 1 foot and 12 inches are exactly the same, 1 foot divided by 12 inches equals 1. Any number divided by itself is equal to 1. Likewise, we can flip it around, take the reciprocal, 12 inches over 1 foot. But since these things are equal to one another, it's a number divided by itself, it's equal to 1. Now, the way a conversion factor works is since it's equal to 1, if you multiply anything by 1, it does not change the meaning, but it may change the appearance a little bit. In this problem, we start simple with something that you could probably do in your head, 4 feet converted to inches. Since there's 12 inches in a foot, we know that this is going to be 48 inches. But to show you how to use dimensional analysis, we take the 4.0 feet and we multiply it by a conversion factor, which is a number equal to 1 that shows us how the two things relate. There were two different ones on the previous slide. We can write it as 12 inches over 1 foot or as 1 foot over 12 inches. We'll pick to write as 12 inches over 1 foot. This conversion factor has two things that are equal to one another, but it's placed so that we end up with foot on top, foot on bottom, and foot divided by foot. Any number divided by itself is equal to 1, and they cancel. Now I'm going to give you a guideline when you're setting up a problem. Take the given and write it as a fraction. Most of the time that means writing it over 1. It just helps you see what cancels a little bit better. So we end up with 4.0 times 12, or 48. Since foot divided by foot is 1, they cancel out and we're left with just inches. We end up with exactly the same answer that we were expecting. It was a little bit more work to do it, but in the process we learned dimensional analysis. In this example, we have 64 inches divided, converting to feet. We can do this problem in our head. We know that 60 inches is 5 feet, because 60 divided by 12 is 5. Plus we have 4 inches left over, which is another third of a foot. So it comes out to about 5.3 feet. Setting up the problem, we'll start by writing the given down as a fraction and choosing a conversion factor. The conversion factor used is still 12 inches equals 1 foot. At least that's the relationship. To write it as a conversion factor now, we'll put inches on the bottom and foot up top so that the inches cancel. And the rule is 1 foot is 12 inches. Inch divided by inch is 1. 64 divided by 12 is 5.3 feet. Now, looking at sig figs, both of these are two significant figures to start with. When we're working on conversions, the number of sig figs we start with is the same number of sig figs we finish with, as long as our conversion factor is a definition. These are considered exact, so they'll have no impact on sig figs. So if I start with 2, I finish with 2. Okay. Looking at this problem, we're asked to convert from yards to inches. And although we may know how many inches are in a yard, let's pretend for a minute that we don't, and instead break down yard into something simpler. Yard can be converted to feet first, and then the feet can be converted to inches. We don't need to do this as two separate conversions. We don't need to get an answer to how many feet there are. We can link everything together and solve it all at once. We just need to know that 1 yard is equal to 3 feet, and 1 foot is equal to 12 inches. Set up the problem by writing the given as a fraction. And we go back to our plan, we see 2 conversions, one from yard to feet and one from feet to inches. In our plan, we used arrows to represent the conversions. Those are my 2 conversion factors. And once they're set up, we just have to substitute in yards on the bottom to feet up top. Double check to make sure your numbers are in the correct place. The number is 1 yard and 3 feet, so yards cancel. And if we were to solve the problem right now, we would have an answer in feet, but we were asked to find inches, so we do one more conversion factor right here. We'll put 1 foot on the bottom so that foot cancels out with 12 inches up top. So cancel your feet, and you're left with 4.5 times 3 times 12, which comes out to, I believe, 162 inches. Now our guideline for sig figs is however many you start with, you should finish with the same number. So since there's 2 sig figs here, I'll round my answer to 2 significant figures at 160 inches. One last problem, this one's a little bit more complicated. There will be a few more conversions along the way. Most people would not know how many fluid ounces are in a gallon, myself included. I would break this down into easier units, going from gallons to quarts, quarts to pints, pints to cups, and cups to fluid ounces. This problem's a little bit longer than the last one. We see by the arrows we have 1, 2, 3, 4 conversion factors. Now our relationships, it's 4 quarts in a gallon, 2 pints in a quart, 2 cups in a pint, and 8 fluid ounces in a cup. So we'll put all of those in as conversion factors, starting with writing the given as a fraction. And again, 4 sets of brackets for the 4 conversion factors. First one gets rid of gallons, so gallons goes on the bottom, quart up top. Again, it's 4 quarts per 1 gallon. If we were to solve the problem now, we would have 16 quarts, but we have to keep converting to get it down to fluid ounces. So next, we're getting rid of quarts. Look only at what you're getting rid of and what you're going to, because that's your conversion factor. Quarts on the bottom, to get rid of it, pints up top. 2 pints, 1 quart, and the quarts cancel out. We're on pints now, so that's what we're getting rid of, and we're going to cups. Only what we're getting rid of and what we're going to shows up in the conversion factor. So pints on the bottom, cups on top. 1 pint is 2 cups, pints cancel. And we have one last conversion factor. We have to get rid of cups and go to fluid ounces. And this is 8 fluid ounces per 1 cup, so that cancels. Math, now we have 4 times 4 is 16, times 2 is 32, times 2 is 64, times 8 gives us, to 3 significant figures, 512 fluid ounces. And we're set with that problem. Now, the next couple slides will sum up what we did and how to go about setting up your conversions. Remember, conversion factors are based on definitions, so anytime it's a definition, it's an exact number, it's infinite sig figs, and our rounding is based only on the number we started with. When we're setting up a problem, begin by writing out the given and the find, then identify the relationship between the given and the find. If the conversion is more than one single step, create a plan for solving it. Write out each relationship that will be used. And you noticed in the last problem we didn't write out the relationships. As you get better at these and as you practice them, that's a step that you can combine, that you can write out the relationships as your conversion factors as you go, rather than planning them out first. When it comes time to set up the problem, write the given as a fraction. Add brackets for each of the conversion factors, and then put in your conversion factors so that whatever you're getting rid of cancels. Our last step is simplify, cancel units, solve, and make sure you check the units to make sure everything works out.